Hello, this is Dr. Flight, and this will be a fairly short, quick little run through on some things to remember from a preliminary standpoint when we begin to look at cluster analysis. And when I say preliminary, I mean that this is like as we're getting our data set up, we want to make sure things are in good shape. So as we approach cluster analysis, there are some things to consider. First of all, we want to make sure we have a large sample size, large enough to group respondents into multiple clusters. So that'll be one of the things that we certainly think about, although there's not a hard and fast rule on sample size. We need to have adequate numbers in each cluster to be able to differentiate groups that we have. We also will be concerned about outliers. Outliers will be something to look for in the data to eliminate. Outliers will certainly cause some problems in our cluster solutions. Also, as we begin the process, we'll have to answer some questions as they relate to the method that we use to form the clusters. So statistically speaking, there will be a number of different options available to us. Most importantly is the option that instructs the software to calculate distance between observations and then distance between clusters. So we want to be able to group respondents that are similar to each other, that are close to a cluster center. And we want to make sure that cluster centers are far apart from each other, so that distance that we want to have created needs to be measured and needs to be created actually. So those methods are things that we want to think about. Lastly here, one of the things that this method is sensitive to will be scale issues. So if you have data that's in different scales, then standardizing the data will need to be performed. Okay, so when we think about sample size again, it's not necessarily a specific number by variable that we're looking for, but we need to have sufficient sized representations in each cluster. So, if we have a cluster that only has a handful of observations, then that's probably not going to be sufficient. And actually what we'll look to do is probably change the number of clusters that we have in order to be able to have sufficient numbers in each cluster that's available that we create. So minimal group sizes then are based on the relevance of each group to the research questions and the confidence that we have that those numbers within each cluster are sufficient. So again, there's not a hard, fast rule on numbers per group or numbers of observations per variable, but rather when we look at the groups or clusters together and we look at the spread of observations, that'll actually help dictate how many clusters we ultimately have. So that's a little bit different. That's a little bit of a different methodology where we use, where we don't have, like I say, the hard, fast rule to help guide us there. Some other considerations which were not mentioned earlier are some assumptions that need to be made. Again, we're going to talk about outliers here, other issues too. One thing we'll want to avoid are variables that do not mean or aren't significant in contributing to group membership. So it's kind of like a non-significant variable in a variate, like a regression or something along those lines, or a factor loading that's not very strong. We want to drop those. And so that's, again, we'll want to drop those types of things here as well. We will find that outliers are particularly troublesome in cluster analysis. So the attention that we draw to outliers needs to be stronger here. One one or two respondents that are out of place could drastically impact the clusters that are formed. So cluster formation is actually very sensitive to outliers. And so that would be a problem. Highly or correlated variables or variables that are too highly correlated could be a concern. So like our other multivariate techniques, highly correlated variables or multicollinearity could disproportionately affect the groupings that we have, the partitioning of the observations, and then finally scale differences. So again, one of the things that we'll look at and just mention quickly is that we'll want to standardize our data. So getting back to this whole idea of concerns here, and again, we are exploring and creating solutions, and there may be multiple solutions, which means there may be multiple clusters that are designed, and the cluster membership may change pretty quickly and pretty rapidly when we're analyzing the data. So any respondent that seems out of place, that doesn't necessarily represent the population, is going to have the effect of impacting the cluster memberships and how clusters are formed. So we certainly want to, look to take out those as we move forward. If we feel like there's a reason for having those respondents in there because they represent a group of relevant consumers or relevant individuals in the population, then we have merit to keep them. But we need to just be careful about how we define those outliers and going through the processes of taking them out. So the outlier then could appear as a single observation, and what might happen is if the observation is so out of characteristic of the data, they can form their own cluster in and of themselves. So that would be a problem, and that would be significant. So one of the rules is a single observation cluster. So a single one observation in a cluster that is not aggregated into the other clusters until at least 10 steps in may be an outlier. So that's one of the rules that we can think of, one of the rules of thumb to go by. So in a hierarchical cluster analysis, what happens is individual respondents are grouped one by one together, and every time a respondent is added, the groups change and they get recalculated or recalibrated. And so if we have an individual who doesn't group within 10 iterations, then they are well outside the norm typically of what we would think as normal. So we have graphical demonstrations of this as well. The iteration table will help us with this first point, but then there are also other techniques and graphs like a profile diagram or a dendrogram, which we can look at as well. Keep in mind we're going to want to delete single observations, but when we do, again, we can see vastly different results in different clusters every single time we run the data after we eliminate a data point. So if we eliminate an outlier, we need to rerun the data and continue that process numerous times, and that would most likely be the approach. So identifying outliers in advance may be very difficult to do, but detecting them as we go, rerunning the data would be more in line with this exploratory type of a technique. So here's a profile diagram, and this is kind of like a line chart, I guess. SPSS doesn't necessarily do these naturally as a graph. So you could put your data in something else like Excel and then create this type of chart. But just note that like an outlier or an object like this or these guys here, something like this, these outliers, they really are on the edge or outside of what we would expect in terms of responses by the data. So you know, each line it represents an individual respondent by 7 different variables. And if these respondents are taken out, then we would actually have a very different cluster analysis. But this is just an illustration of one that might exist. Okay, so this is not, and again, this is not a chart that's readily available in SPSS, but it is a chart that is sometimes used to illustrate where outliers may form. One chart that is available in SPSS is the Dendrogram, and this is actually a fairly common um, data representation that you'll see. And one of the ideas here is that early on in the process, so early on in the different iterations, if you will, we have different labels or different observations down the side here. And basically what's happening is in the first stage here, there's really no groupings. Everybody's their own individual cluster. And then as you go through multiple clusters, then or multiple iterations, then clusters form together. This is a cluster, and this is a cluster. That's a 2-cluster solution there, and it represents all of these individuals here. What they say is that when you have a long string like this early on, then there may be an indicator of, so number 5 here may be an indicator of being an outlier. That may be the problem with that particular one. Although this is somewhat difficult to follow, we'll walk through some examples and see if we can't come up with some examples of outliers in the illustration process of this of doing cluster analysis. Other elements that we're concerned about, we mentioned correlation between variables. Right, so cluster analysis is more effective if variables are not highly correlated. So each variable should represent a different population characteristic, so they don't necessarily have to go together. That's not necessarily what we're looking for. They can be correlated, but they should not be highly correlated. So that would be like, again, the way we think about multi-collinearity. So if variables are highly correlated, the common characteristic may be disproportionately large in terms of its influence on placing individuals in clusters. So multicollinearity has the effect of having an overemphasis of a particular trait on a particular group. So while there are not specific cluster analysis guidelines for multicollinearity, you can look at you can look at the different tests that we would normally do for multicollinearity. Some applications of cluster analysis use the Mahalanobis procedure. However, that's not available in SPSS. So if you do look at if you do look at multicollinearity, if you do the VIF or tolerance measures in a regular regression, that could be beneficial to at least get a gauge. If nothing else, at least run a correlation matrix, and anything above a 0.8 be concerned about. Okay, so that's kind of thinking about correlations. We also mentioned this idea of scaling. So I'm just going to pull up this information. We have a standardization formula, but we can also do the standardization procedure in SPSS. Again, if you have variables that have different scaled values, that can be a problem when we run our SPSS or our cluster analysis in SPSS. So when you go to descriptives, under analyze descriptives, when we put in our continuous variables, there's a little checkbox down at the bottom that will ask you or refer to you as creating new variables, allow you to create new variables that are standardized. So go ahead and do that if your variables have different scaled values. Okay, so that's creating a z-score then for each observation. When you do that, the data will have a mean of 0 and a standard deviation of 1. That's what will result as a process of standardizing your data. Okay, so other assumptions that we can relax to some extent would be linearity, normality, and homoscedasticity. So these would be ones while we're concerned about multicollinearity, we're concerned about other effects of the actual data. These assumptions that we would normally have within a multivariate environment can be relaxed to some extent because the data process does not rely on these linearity, normality, and homoscedasticity, so that's fantastic. And finally, as we move forward, remember outliers can be problematic, right? So outliers may be individuals after running the cluster. They may be individuals that are very, very far from a center or very distant from others within a cluster. We can use graphic profiling diagrams, so we can do the profiling diagram or the dendrogram to look at maybe identifying some of these outliers, right? Additionally, and probably more importantly, we can find outliers who form their own clusters, especially if an individual has not been assigned a cluster within 10 iterations of the process. So that would be, and that's something we would see in hierarchical regression. So that could be a way to identify our outliers as well. The other key thing I want you to take away from this is standardizing your data. Okay, so outliers, standardizing your data, making sure that you're using variables that are relevant and that are not, that don't share the same variance, that don't correlate too strongly with each other. Those would be the other things to think about. Okay, so this is like just a preliminary before you start your analysis, things to be concerned about or think about as you move forward and begin the cluster analysis process. Thanks. Let me know if you have any questions.